String theory landscape multiverse. In string theory, the concept of a landscape of solutions suggests the existence of approximately 10 to the 500 distinct vacuum states, each representing a different configuration of the universe's fundamental constants. Advocated by Leonard Susskind and others, this idea implies a multiverse in which each universe exhibits its own physical laws, emerging from the compactification of extra dimensions in string theory. Black hole cosmology. Some speculative theories in theoretical physics suggest that black holes may serve as cosmic seeds for new universes. According to this idea, the singularity within a black hole could give rise to a baby universe with its own space-time and physical laws, possibly differing slightly from its parent universe. The printing press, invented by Johannes Gutenberg around 1440, used movable type to copy texts quickly and cheaply. It boosted literacy, spread knowledge, and fueled movements like the Renaissance, Reformation, and Scientific Revolution. Euclid's Elements, shown here, was written around 300 BCE. It presents geometry using definitions, axioms, and proofs to build a logical framework for understanding space and form. It became a foundational text in mathematics and was used as a standard reference for centuries. Widely produced after the invention of the printing press, it shaped scientific thinking, influenced education across Europe, and set a lasting model for clear deductive reasoning in both science and philosophy. Johannes Gutenberg, 1600 to 1468, was a German inventor best known for developing the first practical method of printing with movable metal type. Around 1440 in Mainz, he combined existing technologies such as the screw press, oil-based inks, and cast metal type to create a printing press that could produce books quickly and with consistent quality. His most famous printed work is the Gutenberg Bible, completed around 1455. It demonstrated the press's ability to mass-produce large volumes of text with high precision and aesthetic quality. The invention marked a turning point in European history, leading to rapid dissemination of knowledge, growth in literacy, and the spread of ideas central to the Renaissance, Reformation, and Scientific Revolution. Our universe originated from a single, extremely dense and hot point, an event known as the Big Bang. This theory explains the expansion and evolution of the cosmos from its earliest moments. In the 1920s, Edwin Hubble observed that galaxies are moving away from us, showing that the universe is expanding. His discovery provided key evidence for the Big Bang theory. Confirmation came in 1965 with the detection of the cosmic microwave background. This faint, uniform glow is the cooled remnant of intense radiation from the early universe.
Robert Wilson and Arno Penzias were American physicists who in 1965 accidentally discovered the cosmic microwave background, CMB, a key piece of evidence for the Big Bang theory. At the time, they were working at Bell Labs using a sensitive horn antenna designed for satellite communication experiments. While testing the instrument, Wilson and Penzias detected a persistent background noise coming from every direction in the sky. Their discovery confirmed a major prediction of the Big Bang model and provided strong evidence against competing theories such as the steady-state model. In 1978, Wilson and Penzias were awarded the Nobel Prize in Physics for their work. The CMB remains one of the most important observations ever made. The concept of zero as both a placeholder and a number was first developed in India. By the 5th century CE, Indian mathematicians had begun using a dot or small circle to represent zero in positional notation. The mathematician Brahmagupta, writing in the 7th century, was the first to define zero as a number and describe rules for arithmetic involving zero and negative numbers. The idea of zero spread from India to the Islamic world and eventually to Europe, where it transformed mathematics. It enabled the development of algebra, calculus, and digital computing. Zero is now a foundational element in all modern number systems and mathematics.
Brahmagupta, born 598 CE in Rajasthan, India, was a mathematician and astronomer who defined the use of zero as a number and not just a placeholder. Writing in his seminal work Brahmasphutta Siddhanta, he laid out rules for arithmetic operations involving zero and negative numbers. He described it as the result of subtracting a number from itself and gave rules for addition, subtraction, and multiplication involving 0. Brahmagupta used a dot underneath numbers to represent the number and referred to it as shunya, meaning empty. His work built on earlier Indian mathematical ideas, but he was the first to formalize 0 in a way that made it usable in calculations.
Mary Anning, 799 to 1847, was a pioneering English fossil collector and paleontologist, known for her major discoveries along the Jurassic coast in Lyme Regis, Dorset. Born into a poor family, she received little formal education but gained scientific knowledge through hands-on work and observation. Anning discovered the first correctly identified ichthyosaur skeleton when she was just 12 years old. She later unearthed the first complete plesiosaur and one of the first British pterosaur specimens. Her finds provided key evidence for extinct species and ancient ecosystems, influencing early 19th century debates on geology and evolution. DNA, deoxyribonucleic acid, is the molecule that carries the genetic instructions for life. It is composed of 2 strands forming a double helix with sequences of 4 nucleotide bases: adenine A, thymine T, cytosine C, and guanine G. These bases pair A with T, C with G to encode information used to build and maintain organisms. In humans, DNA is organized into 23 pairs of chromosomes located in the nucleus of nearly every cell. The complete set of human DNA is called the human genome. It contains about 3.2 billion base pairs and an estimated 20,000 to 25,000 protein-coding genes, along with large regions of non-coding DNA that regulate gene activity. Rosalind Franklin, 1920 to 1958, was a British chemist and X-ray crystallographer whose work was central to understanding the structure of DNA. She studied physical chemistry at Cambridge and later specialized in X-ray diffraction techniques, applying them to biological molecules. While working at King's College London in the early 1950s, Franklin produced high-resolution images of DNA fibers. One of her photographs, known as Photo 51, provided key evidence that DNA has a helical structure. Franklin was also a pioneer in studying RNA and viruses. Though not credited during her lifetime, she is now recognized as one of the key figures in the discovery of DNA's structure.
Pacific City, the 360 beach photo that you're in, is characterized by its sandy shoreline, dunes, and proximity to Cape Kiwanda, a sandstone headland offering views of the ocean and surrounding areas. Recreational activities at Pacific City Beach include surfing, fishing, and beach combing. The area is also known for the launching of dory boats, a traditional fishing practice in the region. During the Apollo missions, 1969 to 1972, astronauts conducted geologic surveys, collected lunar rock and core samples using drills such as the Apollo Lunar Surface Drill on Apollo 15, and deployed subsurface heat flow instruments. These missions revealed a regolith rich in basaltic minerals, anorthosite, and rare metals, establishing a baseline understanding of lunar geology and pointing toward the moon's potential as a mineral reservoir. NASA's Artemis program will revisit the lunar surface, especially polar regions, with modern drilling tools to map and extract resources. Permanently shadowed craters hold water ice, which can be split into hydrogen and oxygen, critical for life support and rocket fuel. Additionally, the lunar regolith contains around 1 million tons of helium-3, a potential clean fusion fuel that could underwrite future energy systems. These resources will serve broader projects such as space-based solar power, enabling continuous energy beamed back to Earth from lunar-manufactured satellite arrays. As lunar mining and resource utilization mature, plans envision the moon as a base for large-scale colonization and support for cislunar space habitats. Indigenous regolith mining can yield construction materials and propellant, dramatically lowering costs compared to launching from Earth. Self-sustaining lunar settlements and orbital infrastructure will support billions of people via manufacturing, energy production, scientific research, and logistical services. Over time, a robust lunar economy will evolve into thriving civilizations on the moon and in cislunar space. Asteroid Bennu, a carbon-rich near-Earth rubble pile, has become a prime target for future mining due to its abundance of water-bearing minerals, organic compounds, and unexpected salts. NASA's OSIRIS-REx mission returned approximately 120 grams of pristine Bennu material, revealing a rich assemblage of hydrated clays, magnetite, carbonates, sulfides, Na-rich phosphates, and chlorides, signaling past interaction with briny fluids in its parent body. The samples also contain high concentrations of carbon, water, complex organics, amino acids, and the 5 nucleobases of DNA RNA, suggesting Bennu may preserve key ingredients for life. Its substantial water content, on the order of 1% by mass, offers potential in situ resources for hydrogen and oxygen fuel production, making Bennu not only a scientific treasure trove, but also a compelling candidate for future space mining and in-space resource utilization. Mars presents a wealth of exploitable in situ resources that will form the backbone of any large-scale colonization. Its abundant water ice, found in polar caps, subsurface glaciers, and permafrost, can be extracted and electrolyzed into hydrogen and oxygen for rocket propellant, life support, and fuel for the Sabatier reaction that converts atmospheric CO2 into methane. The regolith and volcanic formations harbor iron, aluminum, titanium, chromium, nickel, and even rare earth elements, all of which can be processed into construction materials for habitats, infrastructure, and radiation shielding. Autonomous robotic systems and 3D printing techniques will likely spearhead mining and fabrication efforts, enabling sustained settlements. Combined with solar and nuclear energy, in situ resource utilization will eliminate Earth dependence, paving the way for a self-sufficient human presence. Over time, these capabilities will support billions through expanding cities, agriculture, manufacturing, and industry across Mars. Phobos and Deimos, Mars's small, asteroid-like moons, offer rich opportunities for mining volatiles, metals, and construction materials to support in-orbit habitats around Mars. Their low gravity and orbital position allow extraction of water ice, light elements, magnesium, potassium, oxygen, and even heavier metals using robotic mining techniques. Materials will be processed into propellant, structural components, and radiation shielding, then assembled into large space elevators or space habitats anchored to Phobos or Deimos. This in situ resource utilization will enable the construction of vast orbital settlements, housing billions by supplying raw materials for habitat fabrication, fuel for interplanetary transport, and platforms for industry, science, and energy production within the Mars system. The combined estimated value of all accessible asteroids, including the dwarf planet Ceres shown here, the Moon and Mars, is roughly US 700 quintillion, an almost unimaginable reservoir of resources. This ultra-high valuation reflects the total in situ worth of metals like iron, nickel, gold, platinum, and water ice scattered across the asteroid belt and near-Earth space bodies. The sheer scale of this valuation highlights the potential to redefine space colonization, industrial supply chains, and spark a quintillion-dollar space economy revolution driven by off-Earth resource access. Mariner 4 was the first successful mission to capture close-up images of Mars, launched by NASA on November 28, 1964, and performing a flyby on July 14, 1965. Operated by the Jet Propulsion Laboratory, JPL, the spacecraft transmitted 21 images of the Martian surface, revealing a cratered and barren landscape that challenged earlier expectations of a more Earth-like planet. In their eagerness to see the results, JPL staff manually assembled the first image data using printed numerical readouts of brightness levels. They affixed the data strips onto a board and colored them by hand in a paint-by-numbers style, creating a now iconic crayon mosaic. This improvised visual, known as PIA 14033, provided the first human-made image of Mars from space and remains on display at JPL as a testament to scientific curiosity and ingenuity.
The big announcement is that there was a new paper that came out this week in the journal Nature that says a possible sign of biosignature found on Mars by the Perseverance rover. Now, this is a story that we have been tracking and following for about a year now, when the Perseverance rover found this really cool rock on the surface of Mars. It looks like a piece of sedimentary rock where you've got this silt and clay that is hardened, and then these little nodules that look like leopard spots inside the rock. And when this rock was first discovered, scientists were already pretty excited by it because you've got these little concentrations of iron in those nodules. And now we've got a new paper that is making the case that this is evidence of some kind of past life on Mars. Now, not current life on Mars. We're not seeing bacteria. We're not seeing fossils.
Not to scale, this 3D model of Phobos has been enlarged for educational purposes. Phobos is the larger and innermost of Mars's 2 moons, measuring about 27 kilometers across at its widest point. It orbits just 6,000 kilometers above the Martian surface, making it the closest known moon to its parent planet in the solar system. Heavily cratered and irregular in shape, Phobos is dominated by the large impact feature Stickney crater and is thought to be a captured asteroid. Due to tidal interactions, Phobos is gradually spiraling inward and is expected to either crash into Mars or break apart into a ring system within 30 to 50 million years. Its proximity and dynamic fate make it a key focus in Martian satellite research and future mission planning. Not to scale. This 3D model of Deimos has been enlarged for clarity and educational purposes. Deimos is the smaller and more distant of Mars's two moons, with a maximum width of about 12 kilometers. Irregular in shape and lightly cratered, it orbits Mars every 30.3 hours at an altitude of roughly 23,500 kilometers. Composed of dark, carbon-rich material, Deimos is believed to be a captured asteroid from the outer solar system. Its smooth surface and stable, slowly receding orbit distinguish it from its companion Phobos and make it an enduring subject of interest in Martian satellite studies. Valles Marineris is the largest canyon system in the solar system, stretching over 4,000 kilometers across the Martian equator and reaching depths of up to 7 kilometers. Named after NASA's Mariner 9 spacecraft, which first imaged it in 1971, the canyon complex dwarfs Earth's Grand Canyon in both length and depth. It consists of interconnected chasms, including ice, tithonium, and coprates, and likely formed through a combination of tectonic activity, crustal stretching, and erosion. The region provides key insights into Mars's geological and climatic history, with exposed rock layers revealing ancient processes such as landslides, lava flows, and potential water-related erosion. Valles Marineris remains a major target for scientific study due to its complex structure and potential clues to the planet's past habitability. Olympus Mons is the tallest known volcano in the solar system, rising approximately 22 kilometers, 13.6 miles above the Martian surface, nearly 3 times the height of Mount Everest. Located in the Tharsis volcanic region of Mars, it spans about 600 kilometers in diameter and features a gently sloping shield structure formed by repeated slow lava flows. At its summit lies a vast caldera complex approximately 80 kilometers wide, the result of successive volcanic collapses. Olympus Mons' immense size is attributed to Mars's lower gravity, lack of tectonic plate movement, and extended volcanic activity over hundreds of millions of years. As a prominent geological feature, it offers critical insights into the planet's volcanic history and interior dynamics. Orbital mapping and scouting missions are selecting optimal settlement zones on Mars by identifying surface ice, terrain risks, and energy availability. Satellites like Mars Reconnaissance Orbiter and Mars Odyssey are producing high-resolution maps of subsurface water, surface temperatures, and elevation data. These inputs guide the placement of initial bases near stable terrain with access to ice and consistent sunlight. Landing corridors and cargo drop zones are being planned based on this orbital intelligence. On the surface, robotic missions are validating the core systems that will operate Martian settlements. Rovers and orbiters are testing autonomous navigation, local weather forecasting, communication relays, and remote-controlled construction. These systems are being hardened for long-term use. Commercial providers will start routine cargo deliveries using robotic landers, building up to continuous logistics operations. These early outposts will evolve into full surface settlements with functioning power grids, transport systems, and networked control infrastructure. NASA is constructing a transport and operations chain from Earth to Mars, beginning with lunar missions under the Artemis program. The Orion spacecraft, Space Launch System (SLS), and Lunar Gateway Station are part of a long-term Mars architecture. These platforms are already flying or under construction and will serve to test propulsion systems, crew operations, and life support in deep space conditions. Mars missions will follow a path through the Moon, using it as a staging ground for training, equipment testing, and long-duration mission rehearsal. Robotic missions, such as the Mars Sample Return Program, are already in motion and will validate procedures for surface-to-orbit ascent, sample containment, and autonomous rendezvous. These capabilities directly support human expeditions to Mars. NASA will launch its first crewed surface mission around 2040, using modular landers, nuclear propulsion, and surface habitats based on Artemis prototypes. Astronauts will begin long-duration stays on Mars, continuously expanding a permanent American-led presence. SpaceX is leading Mars colonization efforts with Starship, a fully reusable launch system capable of delivering 150 metric tons to the Martian surface. The company is building a high-frequency launch architecture, with daily Earth departures during transfer windows and orbital refueling as a standard operation. Initial missions will send robotic cargo ships loaded with solar arrays, life support units, and in-situ resource utilization (ISRU) systems. Human missions will follow once these systems are active and stable, forming the foundation for long-term surface operations. Elon Musk's goal of building a self-sustaining city of 1 million people on Mars is driving Starship's development. Mass production, fleet scaling, and automation will support continuous migration and rapid build-out of Martian infrastructure. Crewed launches will increase in frequency, supported by automated cargo delivery and surface construction. SpaceX will establish regular interplanetary transport, building the first functioning pipeline between Earth and Mars for people, materials, and goods. The Mars Curiosity rover, part of NASA's Mars Science Laboratory mission, was launched in November 2011 and successfully landed in Gale Crater on August 6, 2012. Designed to assess whether Mars ever had environmental conditions suitable for microbial life, Curiosity carries a suite of advanced scientific instruments, including a robotic arm, drill, spectrometers, and environmental sensors. Its primary mission is to study the planet's geology and climate, with a focus on the layered terrain of Mount Sharp, a central peak within Gale Crater. Curiosity has provided conclusive evidence of ancient freshwater lakes, organic molecules, and seasonal methane fluctuations, all pointing to a more habitable past. The mission continues to operate beyond its original timeline, offering valuable data for future human exploration and deepening understanding of Mars's geological history. NASA's James Webb Space Telescope has provided the most detailed mid-infrared view to date of the planetary nebula NGC 1514, revealing its complex structure with unprecedented clarity. At the center of this nebula lies a binary star system, one of which is a dying star that has expelled its outer layers of gas and dust, forming the intricate nebular rings now visible. Historically observed since the 18th century, including by William Herschel, who also discovered Uranus, NGC 1514 once appeared as a cloudy object, but is now shown to possess layered rings, clumpy inner clouds, and V-shaped density structures. The image highlights a vibrant interplay of colors and textures, with pink and orange gas formations surrounded by cooler blue regions, all set against a star-filled background. Webb's observation marks a significant advancement over earlier views, such as those from the WISE telescope in 2010, showcasing the power of modern infrared astronomy to study stellar evolution. The James Webb Space Telescope has made its first discovery of an exoplanet using direct imaging, a significant milestone in its mission. The planet, similar in mass to Saturn, is the lightest ever detected by this method. This breakthrough shows Webb's ability to observe planets with masses comparable to those in our own solar system, expanding our capacity to study planetary formation and evolution. The exoplanet orbits TWA7, a nearby young red dwarf star seen nearly face-on from Earth. This orientation provides a clear view of the system's debris disk, including 3 distinct dust rings. The planet appears within a gap in one of these rings, imaged in infrared by Webb's mid-infrared instrument, MIRI. Ground-based telescopes had previously mapped the disk's structure, but MIRI's coronagraph allowed astronomers to block the star's light and reveal the much fainter planet, located roughly 50 astronomical units from its host. On the 3rd anniversary of the James Webb Space Telescope's science operations, astronomers are highlighting new observations of a small portion of the Cat's Paw Nebula, an active star-forming region. Known for its dense molecular cloud, Webb's infrared imaging reveals fine structures in the gas and dust that were previously invisible, helping researchers trace the complex interactions between young stars and their surroundings. In this section of the nebula, bright young stars are shaping their environment by clearing away nearby material. These stars appear in blue against a backdrop of orange-brown dust arranged in loops and ridges. At the center and top right of the image, compact glowing regions mark sites of ongoing star formation. The radiation and winds from the newly formed stars will eventually erode the local clouds, halting further star formation in this part of the nebula. Messier 82, also known as the Cigar Galaxy, is a compact starburst galaxy forming stars at a remarkably high rate, about 10 times faster than the Milky Way. Though smaller in size, it outshines our galaxy by a factor of 5. Its central regions are dense with gas and dust, fueling intense star formation activity that remains hidden in visible light. However, observations in infrared light reveal the full extent of this activity, including hundreds of massive star clusters, each holding hundreds of thousands of stars. The likely cause of this starburst behavior is gravitational interaction with a nearby larger spiral galaxy, which has funneled gas into M82's core. This influx of material has triggered a cascade of star formation and energized the surrounding environment. Infrared imaging also highlights glowing polycyclic aromatic hydrocarbons (PAHs) and warm dust structures that trace outflows from the galaxy's core. These dusty winds appear to be sweeping material out of the disk, shaping the galaxy's visible form and influencing how long its starburst phase can continue. The central region of the Bullet Cluster contains two colliding galaxy clusters, seen flanking a prominent light blue spiral galaxy. These massive structures are among the most energetic mergers observed in the universe. Their collision generates complex interactions between galaxies, hot gas, and dark matter. The visible galaxies represent only a fraction of the total mass. Much of it is inferred from gravitational effects on light from more distant background objects. High-resolution near-infrared imaging of the region reveals numerous faint distant galaxies that were previously undetected. By analyzing the distortions of background galaxies, an effect known as gravitational lensing, astronomers have refined estimates of the total mass in each cluster. The updated mass maps help constrain models of dark matter distribution and provide insight into how galaxy clusters evolve through major collisions. In 2024, JWST captured the Sombrero Galaxy Messier 104 in near-infrared light for the first time, complementing prior observations by Hubble in visible light and Spitzer in infrared. This multi-wavelength view revealed new structural details, including previously unseen clumps in the galaxy's outer ring. Located approximately 30 million light-years away on the edge of the Virgo cluster and viewed edge-on from Earth, the Sombrero Galaxy has a mass of about 800 billion solar masses and hosts around 2,000 globular clusters. Surprisingly, stars within these clusters show unexpected chemical diversity, possibly indicating a history of galactic mergers. WED's NIRCam also detected surrounding red giant stars, further enriching the study of this complex galactic system. This image represents the James Webb Space Telescope's deepest observation of a single target to date, comprising 120 hours of exposure time. Known as a deep field, it captures an exceptionally faint and distant array of galaxies by collecting light over an extended period. The foreground galaxy cluster at the center acts as a gravitational lens, bending and magnifying the light from background galaxies, some of which may have formed as early as 200 million years after the Big Bang. The view is dominated by a massive white elliptical galaxy surrounded by other cluster members and arc-shaped red streaks, which are lensed images of ancient galaxies. A few bright foreground stars with diffraction spikes are also visible. This observation provides a rare window into the early universe's structure and evolution. LINS 483 L483 is a dark molecular cloud with a pair of forming protostars. These young stars create a luminous hourglass-shaped nebula, where ejected material from the protostars interacts with older surrounding matter, creating patterns of light and shadow. Dense dust forms dark voids, while thinner regions allow light to pass, outlining the hourglass. The upper lobe shows a bright orange U-shaped glow transitioning to purples and pinks at the edges. The lower lobe has textured purples and blues with subdued orange emission. Bright central points mark high-velocity outflows. Dark V-shaped areas on the sides obscure the background, but faint stars and galaxies are visible. These protostars are expected to grow to solar mass, potentially forming planetary systems.
This image presents a remarkably crowded sector of the universe, densely packed with galaxies at varying distances. Foreground stars from our own Milky Way, distinguished by their prominent diffraction spikes, are interspersed among a multitude of distant galaxies, some billions of light-years away. Centrally featured just below the image's midpoint is a glowing galaxy group, radiating a soft white-gold hue. This group is seen as it appeared roughly 6.5 billion years ago, during a time when the cosmos was less than half its current age. Galaxy groups like the one shown are foundational components of the cosmic web. Though smaller than galaxy clusters, they are far more numerous and host the majority of galaxies in the universe. These environments are crucial for understanding galactic evolution, as their relatively close configurations foster frequent gravitational interactions and mergers. By studying the behavior and development of galaxies within such groups, astronomers gain valuable knowledge about the assembly of large-scale cosmic structures and the life cycles of galaxies themselves.
Sagittarius C is a star-forming region near the Milky Way's central supermassive black hole. Despite having plenty of dust and gas, strong magnetic fields there might inhibit star formation. This interplay between gravity, turbulence, and magnetism offers insights into star formation in extreme conditions. The composite image pairs wide-scale radio data from Meerkat with a high-resolution infrared view of a section within Sagittarius C. The radio data, covering about 1,000 light-years, shows vertical filaments, supernova remnants, and turbulent gas clouds. The infrared inset focuses on a 44 light-year segment, highlighting red gas clouds, stars, and a notable cyan structure filled with narrow crystalline filaments. Tyrannosaurus rex, often abbreviated as T-Rex, was one of the largest and most formidable carnivorous dinosaurs to have ever lived. Roaming western North America during the late Cretaceous period, approximately 68 to 66 million years ago, T-Rex measured up to 12.3 meters, 40 feet in length, and weighed an estimated 9 metric tons. It possessed a massive skull, equipped with powerful jaws and serrated teeth capable of crushing bone, balanced by a long, heavy tail. Despite its relatively short arms, each bearing 2 clawed fingers, its muscular legs and keen senses made it an apex predator of its time. T-Rex has become an enduring symbol of prehistoric life and remains one of the most studied and iconic dinosaurs in paleontology. Spinosaurus was a large, semi-aquatic theropod dinosaur that lived during the mid-Cretaceous period, approximately 100 to 94 million years ago, in what is now North Africa. Recognized as one of the longest and heaviest known carnivorous dinosaurs, it is estimated to have reached lengths of up to 15 meters, 49 feet, or more. Spinosaurus is distinguished by its elongated skull, crocodile-like jaws filled with conical teeth suited for catching fish, and its distinctive sail-like structure formed by elongated neural spines on its back. Fossil evidence suggests it was adapted to a partly aquatic lifestyle, with features such as dense limb bones and paddle-like feet. This unique combination of traits has made Spinosaurus a subject of ongoing scientific interest and debate regarding its behavior, locomotion, and ecological niche. Pteranodon was a genus of large parasaurs that lived during the late Cretaceous period, approximately 86 to 84 million years ago, primarily in what is now North America. Although not a dinosaur, it was a flying reptile and one of the most well-known members of the parasaur group. Pteranodon had a wingspan that could exceed 7 meters, 23 feet, with long, slender wings adapted for soaring flight over ancient seas. Its toothless beak and elongated cranial crest, varying in shape between sexes, are among its most distinctive features. Fossil evidence suggests it likely fed on fish and other marine life, using its keen eyesight and aerial agility to hunt over coastal environments. Pteranodon remains an iconic symbol of prehistoric flight and is frequently depicted in popular media and scientific reconstructions. Velociraptor was a small, swift, and agile carnivorous dinosaur that lived during the late Cretaceous period, approximately 75 to 71 million years ago, in what is now Mongolia. It measured around 2 meters, 6.5 feet in length, and stood roughly half a meter, 1.6 feet tall at the hip, weighing about 15 kilograms, 33 pounds. Velociraptor is best known for its distinctive sickle-shaped claw on each hind foot, which it likely used to grip or slash at prey. With a long, stiffened tail for balance and a lightly built frame, it was well adapted for quick pursuits and active predation. Its sharp teeth and grasping hands suggest it hunted smaller animals, and its relatively large brain indicates it may have had complex behaviors, making it one of the most iconic predators of its time. Dilophosaurus was a medium-sized theropod dinosaur that lived during the early Jurassic period, approximately 193 million years ago in what is now North America. It measured around 6 to 7 meters, 20 to 23 feet in length, and weighed up to 400 kilograms, 880 pounds, making it one of the largest known predators of its time. Dilophosaurus is most notable for the pair of thin, arched crests on its skull, whose function remains uncertain, but may have been used for display or species recognition. It had a slender, lightly built frame with strong hind limbs for swift movement and sharp teeth suited for a carnivorous diet. Allosaurus was a large carnivorous theropod dinosaur that lived during the late Jurassic period, approximately 155 to 145 million years ago, primarily in what is now North America. It measured up to 9 to 12 meters, 30 to 40 feet in length, and weighed around 1.5 to 2 metric tons, making it one of the apex predators of its time. Allosaurus had a robust skull with dozens of sharp, serrated teeth, and strong hind limbs suited for active pursuit of prey. Its relatively short but powerful arms ended in 3-fingered hands equipped with large claws, likely used for grasping and slashing. With a long tail for balance and a lightly built body, it was an agile and formidable hunter, preying on large herbivorous dinosaurs, such as stegosaurs and sauropods. Simone Biles is an American artistic gymnast and one of the most accomplished athletes in the history of the sport, widely recognized for her extraordinary power, precision, and creativity. Born in 1997, she has earned numerous Olympic and World Championship medals, setting records for both difficulty and consistency. Biles is known for performing original, high-risk skills that few others attempt, some of which are named after her. Her influence has reshaped modern gymnastics, and she is celebrated not only for her athletic achievements, but also for her resilience and advocacy on issues such as mental health and athlete well-being. Biles has also been open about being neurodiverse and having ADHD, a neurological difference that affects attention, regulation, and energy levels. Diagnosed in childhood, she has spoken about using medication to support focus during training and competition. By sharing her experiences, Biles has played a key role in challenging stigma and promoting understanding of ADHD in both sports and broader society. Her success stands as a powerful example of how neurodiverse individuals can excel at the highest levels when supported and understood. Sarah Tipler is a computer scientist at NASA's Glenn Research Center, where she develops essential software for power systems used on the International Space Station, the Orion spacecraft, and the Gateway lunar station. In addition to her technical work, she is actively involved in STEM outreach and innovation efforts, contributing to missions like Artemis that aim to establish a long-term human presence beyond Earth. Her role blends analytical precision with creative problem-solving, supporting the next generation of space exploration. Tipler has spoken openly about her experience with ADHD, a neurological difference that she came to understand more fully after beginning her full-time career at NASA. She credits workplace flexibility, strong mentorship, and thoughtful accommodations with helping her thrive in a demanding environment. Tipler advocates for inclusive practices that support neurodiverse individuals, emphasizing the value of clear communication, kindness, and respect. Her story highlights how people with ADHD can excel in high-performance roles when their strengths are recognized and nurtured. Zooey Deschanel is an American actress, musician, and producer known for her distinctive voice, comedic timing, and whimsical on-screen presence. Rising to fame through roles in films such as 500 Days of Summer and the television series New Girl, she has become a recognizable figure in both independent cinema and mainstream media. Beyond acting, Deschanel is also a singer and songwriter, having co-founded the musical duo She and Him, which blends indie pop with folk influences. Deschanel has spoken publicly about being neurodiverse and having ADHD, a neurological difference that affects attention and energy regulation. She has discussed how her creative interests, particularly in music and performance, have helped her manage the unique ways her mind works. Embracing her ADHD as part of her identity, she advocates for greater understanding and acceptance of neurodiversity, emphasizing that thinking differently can be a powerful asset in artistic and professional endeavors. Autistic individuals in the United States face significantly higher rates of unemployment compared to the general population, with studies indicating they are up to 10 times more likely to be without work. Despite many autistic people possessing strong skills, deep focus, and high reliability, barriers such as non-inclusive hiring practices, lack of workplace accommodations, and a narrow definition of professionalism contribute to ongoing exclusion from stable employment. The situation is further compounded by the social expectations embedded in most jobs, which often prioritize verbal communication, group collaboration, and unwritten social rules, areas that can present challenges for many autistic individuals. As a result of prolonged unemployment or underemployment, a disproportionate number of autistic people experience poverty and, in many cases, houselessness. Without access to sustainable income and supportive services, they may fall through gaps in the social safety net. This underscores the urgent need for meaningful workplace accommodations, such as clear communication, flexible schedules, sensory-friendly environments, and alternative formats for interviews. Creating employment systems that value different neurological styles is not only a matter of inclusion, but a necessary step toward equity, dignity, and long-term stability for autistic adults. Both Bill Gates and Elon Musk identify as being autistic. In 17 of the past 29 years, either Gates or Musk has ranked as the world's richest person. Gates has reflected that he likely would have been diagnosed today and credits his intense focus and deep project engagement, common strengths associated with autism, as key drivers behind his success in co-founding and growing Microsoft. Similarly, Musk has spoken openly about his autism diagnosis, describing a literal interpretation style and deep immersion in technical interests that have propelled his founding of SpaceX, Tesla, and other pioneering ventures. These extraordinary success stories are not anomalies. They reflect what becomes possible when autistic individuals receive proper support and accommodations. Autistic strengths such as intense focus, systematic thinking, and deep curiosity are powerful when nurtured in supportive environments that offer structured communication, flexible work formats, sensory-aware settings, and thoughtful mentorship. When organizations and entrepreneurs recognize and value neurodiversity, they enable autistic individuals to achieve remarkable success, as seen with figures like Gates and Musk, and empower many others to thrive in meaningful, high-impact roles. James B. Jones is an autism advocate and cast member on Netflix's Love on the Spectrum, where he has shared insights from his personal journey living with autism. Diagnosed early in life, Jones has discussed his experiences with special education, asserting that access to supportive programs was transformative in developing his communication and independence. Working steadily in technical support since 2017 and maintaining personal relationships, including having a partner, he exemplifies how autistic individuals can lead fulfilling and self-sufficient lives. Jones has become a vocal critic of stigmatizing narratives about autism, notably responding to public comments that autistic people are incapable of holding jobs or participating in typical societal roles. He strongly rejects these generalizations, instead highlighting the diverse range of outcomes and capabilities within the autism spectrum. Through interviews and social media, Jones emphasizes the need for society to continue advancing acceptance, accommodation, and understanding, reinforcing that with proper support, autistic individuals can thrive across personal, professional, and social domains. Abby Romeo is an autism advocate and artist who first gained recognition through her appearance on Netflix's Love on the Spectrum, where she openly shared her experiences navigating life as an autistic individual. Diagnosed at a young age, Abby faced significant communication challenges early in life, often feeling isolated and unheard. She found a powerful outlet in music and art, which became essential tools for self-expression and emotional connection. These creative passions not only helped her develop her voice, but also became central to her identity and public advocacy. Alongside her mother, Christine Romeo, Abby actively works to promote understanding, acceptance, and inclusion for autistic people. Through public appearances, interviews, and community engagement, she advocates for early support, individualized learning strategies, and recognition of the unique strengths autistic individuals bring to the world. Abby's story emphasizes the transformative impact of creative expression and meaningful support in helping neurodiverse individuals thrive and connect with others. Dani Bauman is an animator, entrepreneur, and autism advocate who first found her creative voice through stop motion and digital animation before she began speaking at around 6 years old. Diagnosed with autism at a young age, she harnessed her deep focus and visual thinking to teach herself animation, ultimately founding her own studio, Danimation Entertainment, as a teenager. Over the years, she has produced numerous award-winning shorts, taught animation workshops to thousands of students with autism, and showcased her work at major events like San Diego Comic-Con. As a public speaker and educator, Bauman advocates for inclusive education and employment opportunities for autistic individuals, emphasizing the power of creative expression and tailored support. Through her workshops and company, she demonstrates how structured environments, mentorship, and recognition of diverse strengths can empower neurodiverse people to pursue fulfilling careers. Bauman's message, "Everything is possible," continues to inspire both the autism community and the broader public to embrace difference and foster opportunity. Autism with high support needs refers to individuals on the autism spectrum who benefit from significant and ongoing assistance in areas such as communication, daily living, and social engagement. While these individuals may face complex challenges, they also possess unique perspectives, preferences, and potential. With the right support systems in place, people with high support needs can lead fulfilling lives, participate meaningfully in their communities, and build strong relationships with those around them. Communication is often an area where alternative strategies are essential. Many individuals with high support needs use augmentative and alternative communication (AAC) tools such as picture exchange systems, speech-generating devices, or sign language. These methods empower individuals to express themselves, make choices, and connect with others in ways that are authentic and effective. With time, consistency, and respect, communication can become a powerful bridge to greater autonomy and self-advocacy. Sensory sensitivity is another key aspect, and it can offer valuable insight into how people experience the world differently. Individuals may respond strongly to certain sights, sounds, or textures, and creating environments that are predictable and sensory-friendly can greatly enhance comfort and well-being. These adjustments are not only supportive but also affirming of each person's sensory preferences and boundaries. Many individuals with high support needs thrive within structured routines and environments tailored to their strengths. Visual schedules, step-by-step instructions, and consistent caregivers can foster independence and reduce anxiety. With appropriate accommodations, people with high support needs can participate in education, arts, recreation, and even employment that aligns with their interests and capabilities. Coordinated support from families, educators, healthcare providers, and community organizations plays a central role in creating opportunities for growth and self-determination. When these systems work together, individuals with high support needs can access the tools and relationships necessary to live with dignity and purpose. Support is not just about meeting basic needs, it's about unlocking possibilities. Recognizing and celebrating the value of people with high support needs means moving beyond assumptions and focusing on inclusion, respect, and opportunity. Their contributions, identities, and joys are just as important as anyone else's, and with meaningful support, they can flourish in ways that are deeply individual and profoundly impactful. Steven Spielberg is a pioneering American filmmaker who, despite achieving global fame, only discovered in his 60s that he has dyslexia, a neurological difference that went undiagnosed through his childhood and early career. He struggled significantly with reading in school, often feeling humiliated during oral reading and facing misunderstanding from educators. Yet he found refuge in visual storytelling, creating amateur films as a boy, and eventually turning that passion into a legendary career. Although reading remains slower for him, Spielberg has developed strategies to manage text-intensive tasks, relying on focused collaboration, oral discussion, and visual imagination. His journey highlights how individuals with dyslexia can harness their unique strengths, such as narrative visualization and creative problem-solving, to flourish in demanding fields. Spielberg's openness has inspired broader recognition of dyslexia as a difference in learning, not a barrier to success. Keira Knightley is a British actress known for her performances in both period dramas and contemporary films, including roles in Pride and Prejudice, Atonement, and Pirates of the Caribbean. Diagnosed with dyslexia at the age of 6, Knightley faced early academic challenges, particularly with reading and spelling. However, her determination to act served as a powerful motivator. She made a deal with her parents that if she learned to read, she could have an agent. This commitment helped her develop strategies to manage her dyslexia and pursue her passion for performance from a young age. Knightley has credited her dyslexia with fostering creativity and resilience, noting that it taught her to work hard and think differently. She often memorized scripts visually, using repetition and imagery rather than traditional reading methods. Her success as a critically acclaimed actress underscores how people with dyslexia can thrive in demanding and text-heavy professions when their strengths are supported. Knightley continues to speak openly about her experiences, helping to raise awareness and challenge misconceptions about dyslexia. Whoopi Goldberg is an American actress, comedian, author, and television personality who has achieved success across multiple entertainment industries, earning an Emmy, Grammy, Oscar, and Tony Award, the much-coveted EGOT. Despite her accomplishments, Goldberg faced significant academic struggles in her youth due to undiagnosed dyslexia. As a child, she was often labeled slow or not smart by teachers and peers, which led to frustration and low self-esteem. It wasn't until adulthood that she learned her difficulties with reading and writing were due to dyslexia, a neurological difference in the way the brain processes written language. Goldberg has spoken openly about her experience, emphasizing that dyslexia does not reflect intelligence or creativity. She credits her imagination, humor, and determination with helping her succeed, despite the barriers she faced in traditional academic settings. By sharing her story, she has become a role model for others with learning differences, advocating for greater awareness, early support, and the importance of recognizing diverse ways of thinking. Her journey highlights the power of perseverance and the value of celebrating individual strengths. Marcus Notch-Persson is a Swedish video game programmer and designer, best known as the original creator of Minecraft, one of the most influential and best-selling games in history. Persson began developing Minecraft in 2009 as an independent project, drawing inspiration from games such as Dwarf Fortress, Infiniminer, and Roller Coaster Tycoon. He released early versions to the public, quickly building a dedicated community that fueled the game's rapid growth. In 2010, he founded Mojang to support ongoing development, with Minecraft officially released in 2011. Persson played a central role in shaping the game's core mechanics, procedural generation, crafting, and sandbox-style open-world exploration. In 2014, he sold Mojang and the rights to Minecraft to Microsoft for $2.5 billion, subsequently stepping away from the company and the game's future development. Jens Bergensten is a Swedish video game designer and programmer who became the lead developer of Minecraft following the departure of its original creator, Marcus Notch-Persson, in 2011. Having joined Mojang Studios in 2010, Bergensten played a pivotal role in shaping Minecraft's ongoing development during its rise to global prominence. Under his leadership, the game expanded significantly through regular content updates that introduced new biomes, creatures, mechanics, and features, enhancing both its creative and survival gameplay modes. Widely respected within the gaming community, Jeb has been instrumental in maintaining Minecraft's cultural relevance and technical innovation, helping transform it from an indie success into one of the most influential and widely played games in the world. Agnes Larsson is a Swedish game developer and the current Minecraft game director at Mojang Studios, known for her leadership in guiding the game's vision, design, and community engagement. Joining Mojang in the mid-2010s, Larsson has become a prominent figure in the Minecraft community, often representing the game in public events such as Minecraft Live. She has overseen major updates that introduce new features, biomes, and gameplay systems, helping to sustain Minecraft's evolution while maintaining its creative core. Larsson is recognized for her collaborative approach to development and her role in ensuring that Minecraft continues to thrive as a dynamic, player-driven platform with broad cultural and educational impact. Nathan Dinnerbaum-Adams is a British video game developer who played a key role in the continued development of Minecraft after joining Mojang Studios in 2012. Known for his deep involvement in coding and game mechanics, Adams contributed to numerous technical improvements and feature updates that expanded Minecraft's functionality and stability across versions. He worked extensively on optimizing the game's codebase and implementing major systems, including advancements in world generation and command functionality. Widely recognized within the community for his technical expertise and playful online presence, often represented by his signature upside-down avatar, Adams has been instrumental in shaping the modern Minecraft experience during its transition from indie success to global phenomenon. A Minecraft Movie is a 2025 live-action adventure comedy film directed by Jared Hess that brings the iconic sandbox game to the big screen. Featuring a star-studded cast, including Jack Black as the expert crafter Steve, Jason Momoa, and Emma Myers, the story follows four ordinary individuals who are transported into Minecraft's pixelated overworld. The film, released theatrically on April 4, 2025, earned over $950 million worldwide, becoming the second highest-grossing video game adaptation in history. Praised by fans for its meme-worthy energy, such as the viral Steve's Lava Chicken track and interactive chicken jockey screenings, the movie has sparked a major cultural phenomenon and inspired plans for a sequel. Thomas Jacob Jack Black, born August 28, 1969, in Santa Monica, California, is an American actor, comedian, and musician famed for his dynamic performances in films such as School of Rock, Kung Fu Panda, and the Super Mario Bros. Movie, as well as his Grammy-winning comedy rock duo Tenacious D. In a Minecraft Movie, 2025, Black takes on the role of Steve, the game's iconic expert crafter, bringing his signature energy and humor to the character. His portrayal includes original songs like I Feel Alive and the viral Steve's Lava Chicken, which became the shortest track to ever chart on Billboard's Hot 100 and the UK Singles Chart. Jason Momoa, born August 1, 1979, in Honolulu, Hawaii, is an American actor, producer, and filmmaker, renowned for roles ranging from Khal Drogo in Game of Thrones to the titular hero in Aquaman. In a Minecraft Movie, 2025, he portrays Garrett the Garbage Man Garrison, a former arcade game champion and video game store owner who becomes one of the four protagonists swept into the Minecraft universe. Momoa's performance infuses the film with humor and energy, portraying his character's fall from fame and subsequent rediscovery of purpose within the chaotic, voxel-based world, a role that earned praise for its comedic timing and relatability.